Hello everybody and welcome to Unacademy classes. My name is Abhishek Mishra. Before starting this class, let's check if I am live or not properly. So let me check it. It will take a few seconds only. So yes, it looks like yes, I am live. So let's begin the class. And I have the chat section also in front of me, so you can just ask your doubts or any questions or general discussion you can do in the comment section. I will be answering them. Before starting this class, there is one new information that I have to just share to you. And this information that I am sharing with you, uh, before doing that, what we will do, we will watch a nice video clip, and this will help you in your gate preparation because this is some sort of competition. And what it exactly is, let's see.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So that was a very nice video clip about Unacademy Combat, a new sort of competition that is initiated by the Unacademy team. And this competition will start right now. It is planned to be start from 16th of December, and I will be providing more information about that and how you should just participate in and also how it will help you. And since this is this will be given by a lot of students, and therefore you can be just participate in this and try to just get a better rank so that your preparation plus your chances of winning something is also going up. So let's see. Let's start the today's class now. So let's start this. So welcome to Unacademy classes, and my name is Abhishek Mishra, as I have mentioned before, and I have secured All India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi. I've got a good teaching experience of 2 years from mechanical engineering in mechanical engineering subjects, and also I have this interest: photo editing, video editing, cricket, football, and I like all sorts of games. So I will be taking this entire class in English, and since, as you can see, I have prepared for GATE examination, I have taught it. So over the years I have accumulated a lot of tips, tricks, a lot of things that I will be sharing with you, so that you can be very well prepared. And after watching my class, you can be rest assured that you have learned something new, and that thing will be 100% coming in use when you give your GATE examination. So this thing, my class that you will be taking today or any day, or watch any of my previous class, they are worth it. So you can follow me on Unacademy. Here is the link. So just visit this link copy the bottom part of the bottom text, that is this, in your browser, Chrome, Safari, Opera, or Microsoft Edge, anything. Just copy it and just go to the website, and you will visit my profile if you enter this link. And that profile you can just click on follow me, and after you have followed me, you can watch classes, my live classes, and also see my notes, the PPTs that I am sharing here, showing here. You can access that from by visiting my website and following me. And also whenever I go live, you can get a notification, so you can attend my classes on Unacademy also, where we will be taking classes in 1 hour duration, short classes, but that classes will also be very worth it, because during the class you will be given live quizzes, live questions that you can answer on the spot. And that is one experience that you have to just take part in to know about. And if you use the code ABHIMI in all capital letters, you can watch free classes on Unacademy app and website. So use this code to watch free classes on Unacademy's app and website. I'm just mentioning this again because this code, if you are not having and you visited the Unacademy app and website, then you just cannot watch their free content. To watch their free content, you have to know this code, that is ABHIMI. And using this code, you will not only get the free content, you will also be just referencing me, so that will help me a lot also. So if you like my classes, you can do this to support me, and also to get free classes, my free notes, all this by single code can be achieved by this code. So remember this and try to use it. And also, if you want to help, or if you want to just provide this information to other student, you can tell them also to do the same, use this code and get the free classes and free notes there. So there is one new thing that I have just showed the video of at the beginning, that is Unacademy Combat. So Unacademy Combat is the India's largest fortnightly competition for GATE. A lot of students will be taking part. So best question by best Unacademy educators will be provided, and this fortnightly means in every 2 weeks, every I think in every second Sunday this will be happening. So you will have a proper time of preparing for this exam and just giving it. It will help you a lot, because you will be just competing with a lot of students, and that is obviously going to encourage you to do your best. And there will be challenging questions curated by Unacademy educators, as I have discussed before. So this is just a general, you can say, interface, how you can just solve the question. This will be the overall layout. And again, you need this special code to attend this Unacademy Combat also. So use this special code, and you can say that why I should attend this Unacademy Combat. It is due to the fact that you can win prizes, and also you will be preparing, and this preparation will help you score good marks in GATE examination. And what better is to both prepare and both win prizes. So super fast and fun real-time ranking. So the real-time ranking means that the ranking will be changing very in a real time, that is in, you can say, regularly, based upon the performance. So if you have scored, for example, good marks, and some other students score more better marks, then he will just go in the top, and you can then go in the next exam by doing the or scoring such marks that you can just go up in the rank. So this is lifetime ranking will also be helpful in keeping track of your progress and where you stand at the moment. And as a lot of students will be taking part, and you can see the ranking is shown like this, so you will know where you stand, and therefore you can just prepare for next exam accordingly. And you can also keep focus on your preparation. Detailed video solution will also be provided. So not only you will be getting the test and it is done, you will also be getting answers after, or solutions after you have given the test. So this is like just giving a test, and after that you will be seeing the solution. So at the end of the test you can know how to solve every question that is asked in the exam. So again, a very good thing, because what if you are giving the test, just remember that you have to know all the questions after you have completed the test solution, and just completed giving the test. You should just go to every question and know how to solve it. If you are not doing that, then there is no just benefit of giving the whole test process. So here is the things you can see how the Unacademy combat is just structured. So you have to score, there will be leaderboards, ratings, and awards. So this all thing you can know more about by visiting the Unacademy website and typing the code ABHIMI there that I have shown in the beginning of the class. And here are the prizes. As you can see, a lot of great prizes are there, and a lot of high prize things are there for you to just win. And these prizes are very good, but the main thing is that you need to just make sure that you are getting a lot of things to learn from this test, and you are also seeing where you are standing and how you can just improve your. So if you are scoring a good rank, then not only your gate preparation will be better, but also you will have this nice chance of winning this prizes. And these are the guaranteed prizes. So if you are just getting one of these ranks, then you will be guaranteed given this products. So you can just aim for this also. And this is starting from December 16, 6 p.m. and you can enroll now. Again, use the code ABHIMI in all capital letters, and you can just enroll here in the Unacademy's combat, and also you can watch the live classes on the website and app. So the app of Unacademy is free to download. It is very proper. You can take part in this combat also. You can attend classes, see what are the upcoming classes, and you can properly see the structure of properly structured preparation material there. So I would just recommend you to just download it and check out for yourself, because it is free, so there is no harm. You should totally do that. And if you are resonating with it, if you are finding it better for your preparation, then just go with it. Watch live classes free. If you want to subscribe, you can do that also. It has certain benefits which are not there in free, but just check out this app. And since this is free, so you should totally do this. You should totally use all the resources that are available, and that are just going to make your GATE preparation better. And here are the things that you will be getting if you are planning to subscribe to Unacademy. So daily live classes, live test and quizzes, structured courses, unlimited access. I have informed about this a lot of time. I will just quickly go through them. So when you are subscribing to Unacademy, you are paying some fee to receive all these features. So live classes will be held daily, and you can ask your doubts and answer poll all the while the class is going on. And there are certain free classes that you can watch, but apart from those free classes, if you want to watch a proper structured course, then you have to subscribe to Unacademy. And also for test series, giving test, you also have to need a subscription. Unlimited access of content will be provided if you subscribe to Unacademy. And here is the subscription price, and as you can see, the prices are very affordable. But if you want to just which you should totally want, and this code that I have provided to you at the beginning of the class, that is must for watching free classes, is also giving you 10% off. So you have to apply this code once, and you will unlock free classes, and you will also unlock 10% extra discount, which will make your final prices like this. And this is the discounted prices. This is the least possible prices in which you can get an Unacademy subscription. The plus subscription is basically classroom type experience, where you will be studying with along with other students, and no cost EMI available on 6 months and above subscription plan for you to take benefit of. So if you are not sure, then just take 1 month subscription and then extend it. And if you are wanting to make savings, then go with 12, 18 or 24 months plan, because they are providing a lot of discount. and this 10% off code which you have applied, which will give you extra discount, which will increase with the amount of your subscription. So just choose according to your budget, according to your need, according to you what you think plan is most affordable one. And according to me, 12, 18 and 24 months are the ones who are most better plan, most affordable plan among the bunch. And there is iconic subscription also, which is for which are for those student who need personal coaching, personalized test series and all that, and you can just use the same code to get 10% off. And here is the least possible price in which you can get iconic subscription. Prices are very reasonable for the amount of content and for the amount of assistance this iconic subscription plan is providing you. And plus and iconic have this benefit again, if you have the budget, go for one of the plans, because time is more important than anything. And if you are investing in GATE examination preparation, just try to study from or try to just prepare from the best possible resource, and Unacademy is definitely the best. And as you can see, just watch the amount of educators there, watch the amount of content that Unacademy is providing, watch the interface there, watch their app. All these things you are getting for this subscription price, which is very reasonable. So just give that price and just subscribe and start your preparation, because at the end of the day you want to score good marks, and this is the best possible route. And I will just again point it out, use this code, watch Unacademy free classes and just subscribe as soon as possible, start giving test. And you can always ask your doubts with me. I will be taking their classes there also. In any subject, if you are having doubt, just message me and just ask me, or just write in the comment section. So again, you have to subscribe because you are getting this benefit. If you want to score good marks, then this is one of the best ways to achieve that. So now we will be starting our class, and we were discussing about casting in our previous class, and we were doing quick revision. And this quick revision that we were doing, we will continue that, and it will take, I think, one more class after this. But let's see what we will be doing in this class. We will be just discussing mainly about numericals and some of the numerical parts, because a lot of theoretical parts were covered yesterday, along with some numerical parts, or quite a few numerical parts also. So we will try to do this revision in the same pace that we did yesterday. So the pace was quite good, we covered a lot of things yesterday. So let's start this class. So this is before just starting this revision, before starting this today's discussion, let's go through what a gating design system has. So it has pouring basin. So pouring basin is the first part with which the molten metal is coming in contact with. So this is the first part, and here you will molten metal, and sprue is the vertical passage through which the molten metal passes, and strainer is just to clean the molten metal, to clear out the impurities. Sprue base wall, inside it we have a splash core, which is to minimize erosion. So because your sprue, after just coming out of your sprue, your molten metal will be very high velocity, and that will obviously can lead to erosion, and therefore splash core is there. And then runner is a not vertical, horizontal passage for it to just pass. And skim bob is the section where light and heavy impurities both got just removed from your molten metal, so that your molten metal can pass through in gate and then just enter the primary cavity. And riser, as we have discussed before, it is there to compensate the shrinkages, specifically liquid and solidification, that is till phase change. All the shrinkages will be compensated by riser. After this, it will be compensated by solid shrinkage allowance. So pouring basin, here are the standards of pouring basin. You can see 2.5D, 25R, D, where D is the topmost sprue diameter. So good design of pouring basin is one which reduces liquid velocity or velocity of liquid metal in the sprue to minimize erosion. So pouring basin here, you can see that its main job is to make the liquid metal enter the sprue such that the erosion is minimized. And here are the standards that we are taking, and the standards are obtained via experimentation. And this are D diameter if is the topmost part of the sprue. Then we will have the height of the pouring basin as 2.5D, and the curvature here is 25R in radius, the small curvature here. So you can see that this pouring basin is what its job is and what it does in this slide. Now we will move forward. I hope you can just understand this, and you can just write this 2.5D, 25R and D. And for pouring basin, you should just write this thing that to minimize erosion, this will be enough, and draw this figure. That will be enough for your revision. Design of sprue. So this is a sprue, and as you can see, the topmost part, that is from 1 to 2, we have pouring basin, which is having height HC. Then we have height of sprue HS from 2 to 3, and the total height is HT. So velocity at 3 will be very greater than velocity at 2. Why it will be such that? Because of Bernoulli's equation, you can find this relation, and in this relation you can see that the velocity is depending upon height. So the height is at the 3, the height is greater. We are measuring the height from the top. So at 3 the height is HT, which is HS plus HC, but at 2 the height is HC only. So velocity will be greater at 3, and you can apply this molten metal volumetric flow rate equation. This is general volumetric flow rate, which is equal to area into velocity. So if you just look into this equation, which is just saying that the volume of molten metal coming into the pouring basin and going out of the sprue is equal, so the A into V is equal to constant, and therefore if V3 is very greater than V2, then A3 will be very less than A2. So from here you can see why we have obtained this area small at the bottom and top at the top of the sprue, why the area is larger, because of this velocity being larger at the bottom. So you can understand here from this equations that why we are getting the design of or the shape of sprue like a tapered section, or like a section where the areas are changing as we move along it. So the ideal shape of sprue is this that you can see in the screen, which is parabola. Why it is parabola? And I have not drawn parabola here. I have drawn just a rough figure, because before doing this we didn't know what the ideal shape is. But now if you apply this, use this volumetric flow rate constant, and also use this velocity is equal to under root 2 gh. So this two relations will give you this relation between height and area, and this is of the form y is equal to x square, which is parabola. So the ideal shape of sprue is parabola, and that shape is what we need, but that shape is what we don't make because of the manufacturing difficulty. So we just use or manufacture a tapered section which also does a similar thing that is done by the parabola. So we have this ideal sprue shape, which is parabola, which you can see I have drawn here the ideal shape. So it will look like this, parabola curve, parabolic curve, and the actual shape is a tapered cylinder. Why actual? Because as I have said, manufacturing difficulty was leading to it. So that was that should be clear now. And air aspiration effect. So if free falling of liquid metal is done, then this will be the shape of the free falling liquid. And if we use a straight cylinder as sprue, then we can get low pressure area where the liquid is not going or falling. So air aspiration will be there. What is air aspiration? Air aspiration is just sucking of air in the low pressure area, and therefore that area where the air is sucked will lead to the absorption of the air with the molten metal, and then the molten metal will be giving a porous casting, so that is obviously not desired. So liquid metal flow with air aspiration effect will occur when your sprue is not tapered or parabola, it is straight. So if you are providing a tapered sprue, you will not get the air aspiration effect. Air aspiration effect: entering of gases from baking of organic compounds present in the mold into the liquid metal stream. So the gases which are generated, they are getting entered into the liquid metal stream, and therefore that will make casting porous and hence weak, and this will produce porous casting. As I have just mentioned, pressure anywhere in the liquid stream should not be negative, because if it is negative, then we will get low pressure area to just suck the air, and therefore this will lead to this absorption of air or mixing of air with the liquid metal stream, which is obviously not desired. So this is, again, you should remember ideal shape and actual shape, and this is for the air aspiration to be avoided. And now let's talk about runner quickly. So to minimize turbulent losses and more surface area, if we are giving, then the section that is usually taken is tapered cross section. So tapered cross section runner is for minimizing turbulent losses, that is the main aim. But since it is having more surface area, and surface area leads to more heat transfer, because more area will be in contact with the liquid metal to lose heat, and therefore there will be a lot of heat losses in this tapered cross section. Not tapered, this is trapezoidal cross section runner. But for a circular cross section or cylindrical runner, we can minimize the heat losses because it will not have a lot of surface area, but here turbulent losses will be there. So you have to choose which cross section of runner you can just use according to the thing that you require. If you require less turbulent losses, go with this trapezoidal, and if you require the less heat transfer or less heat transfer losses, you should just go with a circular cross section or cylindrical runner. Gate or in-gate. So gate or in-gate, as I have mentioned, it is the final cross section or final section after which your molten metal enters the mold cavity, primary cavity. So actual entry point through which the liquid metal enters the mold cavity is gate or in-gate. So a question can come, what is the actual entry point after which your molten metal enters the cavity? The answer should be in-gate or gate. Both are the same. And gating design can be classified into 2 or 3 types, and the types are top, bottom, or parting line gating design, and let's study about them now. So top gating design is this, and you can see that in top gating design, first look into the figure. So in the figure you have a pouring basin. So this is the pouring basin, and this is sprue, and this is your primary cavity. So your molten metal will first be at 1, then it will fall to 2, then fall to 3, then it will fill the cavity, which is here. So this cavity is to be filled by the molten metal, which is falling. And then just filling this thing. So for top gating system, you don't require this derivation where this formula came from, but you can remember how to derive this, because this derivation has not been asked. So it is not just better to just go through this derivation every time. So just remember how we have obtained it and then just move on, and you have to but remember this formula. This formula is very important. You have to remember this. So first of all, we have this first line of equation which is saying the AG, that is the area of gate, VG velocity of gate, and dt is the time which is being taken by this cavity to be filled at dh height, which is the height of this molten metal occupying till which it has occupied this cavity, and am is the area of this cavity or area of mold cavity. So if we just do the if we just solve this equation, then we will find that if we do the integration, then we will find that the total time is tf and the total height is hm, which is to be filled. So in tf time, hm height will be filled, and this will give us the tf filling time. And what we are doing here, you can remember this equation. You don't have to remember all the terms here, just remember this line, that volume of metal, molten metal, in is equal to volume of molten metal inside the cavity. I should write going in, it is more clearer that way. So volume of metal that is going in or passing through this gate will be equal to the volume of molten metal that is inside the cavity, and both volume, if we are doing this both of them putting equal, then we will get this filling time, which is basically volume of mold, that is am into hm, this volume right here. So this volume is your Vm, and Ag is area of gate, and Vg is the velocity of molten metal when it has reached 0.3, that is it has reached the gate or in gate. So that Vg will be under root 2g ht, because this we have seen that velocity will be obtained from Bernoulli's equation, which will be under root 2g h, where h is the height and the height at 3 is ht. And by this using this, we can get this final filling time formula. So remember this formula, very important. Just remember this thing, and if ht is given in the question, then you can use it. If it is not given, calculate it. And if hs is only given and you have no means to calculate pouring basin height, then go with hs only. So there are multiple ways that you can just find the vg according to the situation. So let's talk about top gating system quickly. Velocity of the liquid metal in the cavity is very high. So that is very high. As you can see, the velocity is high due to the fact that it is falling directly into the cavity, and the height is ht, and this will lead to a very high velocity. Possibility of turbulence because of high velocity, again all the things are related. So when you are preparing, if you remember that velocity is high, then you can just decode from that or deduce from that that there will be turbulence and splashing, because they are only happening when the velocity is high. Can be used for ferrous metals, because of the high velocity there will be turbulence, and for ferrous metals we have oxide formation, and oxide formation for ferrous metals are not that much of our not that much to worry, because their oxides are low in density and not that hard and brittle, unlike the non-ferrous metal. So it can be used, top gating system can be used for ferrous metal, even though it is having turbulence and splashing. Favorable temperature gradient of the metal due to fast filling. The velocity will be very high and the temperature gradient will be in a favorable direction due to this fast filling. So these are some benefits, and just remember this formula of filling time. You should note this down, because we will be doing a lot of questions in which this formula is coming, and in lot of gate examination also So yes, Benny, first of all, good afternoon to you. I am doing the revision of the formulas and some theoretical parts of casting. In my yesterday's class, I have done the first part of the casting revision, which you should totally watch, and this is the second part. And I think after this, we will need one more class, and our casting will be completed. Whole theory, formulas, plus some important question. So if you watch these three classes, your casting will be totally completed. So I recommend you to just follow these three classes, and just watch the previous class also, because it will benefit you. If you want, you can totally do that. So let's just discuss these things. So here is the filling time formula, which you should remember, and a lot of GATE examination questions are there in which this formula is used. So this formula is must, just remember this. Now bottom gating system. So bottom gating system figure is looking like this, and here the velocity of the liquid metal in the cavity is negligible. And why it is negligible, you can see by looking at the figure itself. It is not directly falling into the cavity. It is first just falling into this splash core well, and then it is flowing to the runner, and then it is flowing from the gate, passing from the gate, and filling from the bottom the whole cavity. So its velocity will be negligible. No turbulence, because again you should relate what is happening. Since here velocity is negligible, so there will be no turbulence and splashing. So you have to only remember this first point, and this second point is itself clear by that. Can be used for casting of both ferrous and non-ferrous metals because of this no turbulence. This point is coming, because remember, non-ferrous metals have oxides which are having very brittle and hard structures, or which are very brittle and hard, and therefore it will obviously lead to some improper casting, and therefore we need our non-ferrous metals oxides to not form, and if we are having no turbulence, then there will be no oxide formation. Unfavorable temperature gradient of the liquid metal, and therefore non-uniform properties. Why it will be unfavorable temperature gradient? Because of its filling from the bottom, there will be solidification happening, and also cooling happening in the direction which is opposite. So you will find that the overall the here the temperature gradient is not in a single direction, or not in a favorable direction. So therefore non-uniform properties also. And here is the formula of bottom gating design, and bottom gating design formula is also very important. I don't think a lot of gate question has been asked till now using this formula, but you should totally remember this, because there is always a chance that a new type of question comes, and it is not that difficult. And again, you don't have to remember the whole derivation, just remember what is the process by which we can get this formula, and the formula itself. So this is the figure, you should totally remember this figure. And then here is the velocity at 3. It is given by under root 2g ht minus h, where ht is the height of this pouring basin plus height of sprue, and this h is the amount of liquid metal which has filled the you can say the molding cavity. So it at last it will fill whole hm, but at some instant it will fill h, so that we are taking. And this this integration that we are doing here will give us this filling time. So what we are doing, again we are putting the volume of liquid metal that is passing through 3 equal to the volume of liquid metal that is inside this cavity. So both of this volume are equal. Therefore if we are integrating these things, then we will get this filling time, which is having this formula. Again, you have to remember this formula, and the very important thing which you might miss when solving question is this 2. So remember that here a 2 is there, because in the filling time of top gating system you don't have 2 there. So yes, ht will become hm, and that if that becomes, then we will see what will happen. So what will happen, let's talk about it first. So ht can totally become hm, or HM can totally become HT. And when it is happening, you can see this HM will become HT. So your total time will be like this. So your filling time will be 2 times of VM AG under root 2G HT. So this term will be your filling time of top gating system. And you can say your TF bottom, filling time of bottom gating system, is 2 times of top gating system filling time. So that is happening only if HM is equal to HT, and this is just a condition that is leading to this relation. So in this whole slide, you have to only remember this bottom part. Don't remember the whole process, how this is happening. Just remember this bottom part, that TF bottom is equal to 2 times TF top if HM is equal to HT. And again, this formula is very important here too. Don't forget to just write the 2 here, because in the question it is possible that you can forget this. And again, the formula is quite simple. HT is coming first in both the times, and HM is here in minus, and both are under roots. And here there is no HT. Also remember this, because in the filling time of top gating system we found that there is HT here, but in the bottom gating system there is only 2 under root 2G. So remember this little things, and let's move forward. So we have another gating system, parting line gating system. So parting line gating system is giving us advantage of both top and bottom gating system. It is most commonly used gating system. And the parting line, you can see the cavity, primary cavity is divided into 2 parts, A and B, along the parting line. And the A is, so I have written here wrongly, it should be, so let's correct this. Top gate is B and bottom gate is A, because your molten metal is coming from here and flowing like this. So it is just entering the B part of the mold cavity from the top, so it should be top gate. And A part of the mold cavity, after it has completely filled this whole B part, the A part will act like bottom gate. So you have to solve this whole parting gating system by dividing A part and B part into top gate and bottom gate respectively, and doing them separately. So you can do that. And then we have step gating system, which is again not asked yet for gate examination. So we will just quickly see what it is and move forward. So to fill very large size mold without causing turbulence and splashing of liquid metal, we are using this step gating system, where this gate is divided into steps, and this molten metal is entering by just passing through this individual passages. And you can see it is and you can just remember here, it is done to just make the turbulence and splashing, just to avoid the turbulence and splashing. That's it. What is the velocity of the steel at the bottom of sprue if the sprue height is 30 centimeter, and we have to assume the frictional and other losses to be 20%. So this question is quite interesting one to have, because we have frictional losses, so frictional and other losses to be 20%. So here there is one thing which might confuse you in your gate examination. So it is better that you are understanding this very clearly. The velocity at the bottom of the sprue will be, first of all, you can simply give this answer by under root 2gh. And height of sprue here is given 30 centimeter. So HS is 30 centimeter. Totally do that. But here some losses are occurring, which will obviously make this velocity less. So what you have to do, will you find the answer by doing this, or will you get the correct answer when you are doing this? So what is the correct approach to do this question? So Benny, again, if you are watching this session live, then can you provide me what is the correct approach to do this question, first one or second one? The 0.8, which is the factor which will give us which will account to 20% losses due to friction. we should multiply 0.8 outside the under root 2gh or inside the under root 2gh. So I will answer this question in a matter of 15 to 20 seconds. So this doubt can arise that where this 0.8 should be to get the final answer. So let me just answer this very question here, that this is wrong, this is right. So you have to multiply the 0.8 inside this under root 2g to get the final answer. Why you are doing this? You are doing this because you are obtaining this relation under root 2gh from Bernoulli's, and Bernoulli's will give you the 0.8 inside the inside this under root. So your final answer will become, let me just provide you the final answer here, under root 2, and we should give the answer in, I think, meter per second. It should be fine. So it will come out as 2.17. So that will be the answer to this question. Now let's move forward. The optimum pouring time for casting depends on several factors. One important factor among them is, and casting time is depending upon several factors. So it is depending upon location of riser or not. No, it is not depending upon that. Porosity, fluidity, area of the pouring basin. So it will depend upon fluidity, and rest I think you can understand why, because none of this is just making the filling time more. They are not related to that. Porosity will be, again, sand mole will lead to some other things, and location of riser again compensate the shrinkages. Area of the pouring basin, which is again not the factor because it is anywhere not seen in the filling time formula. And fluidity is basically a property which is just giving you the information that how much the molten metal is behaving like fluid. If it is behaving more like fluid, then it can easily fill the whole cavity, and that is what we require. So we have another question here. Let's I will not be doing this question properly full. I will be just telling you what are the steps, what is the concept that we can learn from this question, because this is again revision class. So we are just doing quick revision, quick whole session will be focused on you learning the concepts and just learning tips and tricks and learning the things that are important, which that should be taken care of. And here the first thing that you should be remembering, which can come in handy in other subjects also, that acceleration due to gravity sometimes is given as 10. Then if it is given as 10, then always try to take it as 10 also, because else you will be getting wrong answer. More specifically, that answers will be, if filling the blanks you have to answer, then you should be totally taking this into account 10. So always look if the data that is given, you are taking that exact data or not. And if it is not given 10, then always take 9.81. Height of the downsprue is given, cross-sectional area of base is given, and the cross-sectional area of runner is also given. Assuming no losses, indicate the correct choice of time in seconds required to fill the mold cavity of volume. So you will have this formula where you will put this volume, and it is in mm cube, and then you will fill the put the area of gate, which is again in mm square, and then you have to put the velocity at that gate or velocity at the point 3 as we have discussed in our figure. So that will be under root 2g ht. And here if you are putting all the things in mm, so you have to put this into mm also, and since I have to put it like this, since if it is given 10 meter per second square, so just use this value and put this answer in mm per second square. And ht, so let's see if we can calculate h. So let's see if we can calculate ht or not. So ht is always equal to hs, height of sprue plus height of pouring basin. so height of pouring basin. But if we are not getting this pouring basin height, we can just take this HS and HT equal. So here height of sprue is given, so this one is given to us, and cross sectional area at the base is given, which is used here. So we will here we are not being provided cross sectional area at the top, therefore we cannot find the, also we are not provided with the volumetric flow rate, so we cannot find this HPB, so this will be just taken 0, and your final HT will become this 175 mm, and therefore your answer will become after you can calculate, you can just totally get the answer. So since this is not that much of calculation, let's do that. So it is coming 2.67, so that will be the correct answer here. And now let's move forward. A mold has down sprue whose length is 20 centimeter. So we are given length of or height of down sprue, and it is given in centimeter. Here you should totally be aware of the units, because sometimes it is giving in mm, sometimes the gate question only is giving in centimeters, and sometimes it can also be given in meters. So you have to just take care what units are there, so that you can avoid the mistake involving units. And cross sectional area at the base of sprue, so base of sprue we are taking that as 3, so it is 1 centimeter square. Down sprue feeds a horizontal runner leading into mold cavity of volume. So volume of mold cavity is given. Time required to fill is given, which will totally again be calculated like this: Vm Ag under root 2 GHT. Since HT cannot be calculated, so we will just continue by putting HS there. And here also we can find the correct answer. But remember, if you are putting everything in centimeter, put this G also in centimeter, which will be this. So instead of converting whole thing, convert the G only and put the whole in centimeter itself. And we have other question here, which is providing us this figure where we can see we are given area of top part of the sprue, top section, height of sprue is also given, and pouring basin is shown. So it is expecting us to calculate the pouring basin height, because it is shown in the figure, and also we are provided with this top section of the sprue. So we have this Q is equal to area, and let's take this as 1 2 3. So this is area at 2, velocity at 2, so we can find velocity at 2, and after we have obtained this velocity at 2, we can totally find the height of the pouring basin. So that height of pouring basin will be just added with this 200 to get the total height. So total height HT will be this 200, which is HS, plus HPB, which is the pouring basin height, which how to calculate I have just shown here. And let's see if we have this Q or not. So this Q is here in mm cube per second, so we can totally calculate all these things. And after we have calculated all these things, what we have to calculate in the question, area of the down sprue. So after we have calculated HT, what we can do is we can find V3 by using this formula, and then we can use this volumetric flow rate equation. We have this V3, we have this Q, then we can find the answer, that is A3, which will be our answer. So this whole thing can be done in this manner. The steps are to be followed, and I hope this is clear. And now we should be moving forward. But here don't just take the pouring basin, don't just ignore the pouring basin height and take the sprue height. If you do that, then you will be not getting the correct answer. So while calculating area at 3, take the height above it. So above it you will be getting the height of sprue and height of pouring basin in both. That will give you the total height there. So this was the figure in which I solved the question when I just completed this in my regular class. But since this is revision, we discussed it here only. So we have a next question which is asking us for volumetric flow rate, that is Q. And here to calculate Q we need a area and we need a velocity. And let's see, we have this sprue base diameter and height. So sprue base diameter will provide us this area. So base is the bottom part. So bottom part we will have this height 250 of sprue. And we have the cubical mold cavity, so that's volume can also be calculated. So what we can do here, we can find the velocity by using this formula under root 2g ht, since there is no option of calculating pouring basin height. So we will go with the sprue height only to calculate this velocity at the base of the sprue. So final volume flow rate can be obtained like that. And after we have obtained this volumetric flow rate, let's say Q, this is obtained. So we are asked in the second part to calculate filling time. So that filling time will simply be volume of mold cavity divided by Q. This will be mm cube, this will be mm cube per second. So you will get your final answer in second, in which the question is asking you the value in. So this is another way of doing calculation of filling time. You can also do the calculation by using this formula of filling time, that is TF is equal to VM divided by AG under root 2G HT, and you will find that this bottom part is nothing but Q. So since you have obtained the volumetric flow rate itself here, and I think it should be 1.7, I don't remember the exact answer, but if you have obtained a final value of a Q, then you should totally use that and just avoid this calculation here. So a mold dimension is given here, and it is filled with molten metal through a gate with height h and cross sectional area A, the mold filling time T1. So you are being provided with this information, and it is asking that if filling time is given by T, then what is the ratio of T2 by T1. And you have this information that height is quadrupled, that is 4 times, and cross sectional area is halved. So this, to know this, you have to see the filling time. It is proportional to the inversely proportional to the gate area and under root of HT. So if this AG is half and if this is quadrupled, then you will find that this whole thing is just getting 1. So your filling times after this changes will also remain the same. So T2 by T1 is 1. And here is one more question which is which is taking into account the parting line gate. So that gate will be that system will be like this, where you can see that we have our mold cavity divided into 2 parts. So it will be A and it will be B. So the A part will be, so this part will be bottom, it will be treated as bottom gate system, and this B part will be treated as top gate system. So what will happen, you need to just calculate the filling time, or the filling time is given 10 seconds. So you need to calculate the AG by putting the equations of filling time of this top and bottom gate respectively. So via doing this you can obtain the area of gate and the filling time of bottom gate and top gate. I have already shown you the formulas what they are. Let me show you that again. So for top gate we had this filling time formula, you can use that, and there the volume of mold will be changed only that volume which is having the top gating filling done by the top gating design will be there in this formula, and for bottom gating we will take that volume only where the bottom gating design is being followed. So that will be the process of doing the question here, and you can obtain that answer properly. So let's move forward. This question is I don't think that this can be asked, but if the calculation is easy then it could be asked in GATE examination. But this question is quite lengthy because you have to do calculation 2 times of use these two formulas. So this is a bit lengthy here, but the concept is very good. The concept is that the two parts are here and the two parts are following different type of gating design, that is bottom and top. Then we have this fluidity. So what is fluidity? Fluidity is the ability of the liquid metal to flow into the cavity. So we have two properties in casting which is starting with F, and students might get confused here. We have fluidity, which is a property of liquid metal. Then we have flowability, which is property of molding sand. So don't get confused between these two properties starting with F. Flowability is the ability of the molding sand to fill the mold box properly so that it can just create the mold cavity properly, and fluidity is the property of liquid metal, so it can fill the mold cavity properly to make the casting. So we are doing the spiral test to determine fluidity. And what spiral test is, it is very simple. Distance covered by the liquid metal in a standard spiral before solidification is the value of fluidity. So we have this spiral with a pipe attached to its end, and you can just put the liquid metal inside this spiral, and after passing through sprue, so you will find this liquid metal reaching a certain distance, and that distance will determine how much fluid it is, and it should be very well fluid so that its filling time is not that much, and also it is not solidifying before filling the whole cavity. So you have this property, and what its effect is in fluidity. So if pouring temperature is increasing, your fluidity will increase. Simple. Viscosity, if it will increase, your fluidity will decrease. This is also you can just understand properly. Viscosity will make more losses, so fluidity will be decreased there, and density increase will also lead to fluidity decrease. Percentage water increase will lead to fluidity decrease. And also you have because why percentage water is leading to fluidity decrease? Because what will happen, percentage water will lead to the energy getting used to evaporate that percentage of water, and therefore your heat transfer losses will lead to solidification of the molten metal before intended, and therefore its fluidity will decrease. And surface finish of cavity will obviously increase the fluidity because the losses will be less there. So that will be it for the first part of this today's class. Now we will continue the second part, so let's do that. So before moving and continuing the today's this section, let me just remind you quickly that you can follow me on unacademy.com, and here is the link. Just enter this link and follow me there, because I want more and more students to be present there, and you should totally just spread this word that if you are finding this class helpful, my classes helpful, then you should just spend this word that you can watch my classes, so that you can watch the classes along with your friends or other students, and just take part in the discussion properly. Because when we do the question, I want more students to be present there, so that a lot of good questions can be discussed, and you can also get a company, and it will also support me. So just follow me, and just attend my live classes after that. And when you are visiting Unacademy's website or app, you can watch free classes, but now you can do that only if you have a code, and that code is ABHIMI. So use this code to see the free classes. So that is one thing that you can do, and you can also use this code to get 10% off, because this code is used for that also. If you are using this just for free classes, that is also fine. So this code has this multiple benefits that you can totally take benefit of. So now what we will do is we will continue our class here by discussing about now the rest of the topics. So next is choke area. So let's discuss about choke area. I've already just given you a brief introduction or brief information about choke area, that it is the smallest or minimum cross-sectional area in all of gating elements. So what we are going to do today is we are going to just learn about this choke area and the rest of the things that are here in the slide. So here are the things. Then what we will do is we will do one more part of the discussion after taking break there. So before taking the break, we will have a nice discussion. I think it will take around half or less than half an hour it can take, and here are the slides. So we will cover a lot of things here. Solidification time is also one of the topics to be covered now. So let's do that. So choke area controls the flow of liquid metal which enters the cavity. So you should remember this. Gate question can come, that which is the area which is controlling or regulating the flow of liquid metal entering the cavity. It should be choke area. First parameter to be calculated in all of gating elements, because this is controlling the flow of liquid metal which is entering the cavity. Therefore, we need to calculate it first, and here is the formula of choke area that you should totally remember. So it is mass, that is in, I am now telling you very important thing, because by using this trick you can remember the formula here. So always remember the units here, so that if you just miss one of this one of the parameters here, then you can remind yourself of that by remembering or by finding out what unit is missing. So mass is in kg, this is in kg per meter cube, and this will be in seconds. This will be unitless because this is a correction factor, and this will be in meter per second. So you can see your final unit will come into meter square, that is the unit of area. So if you are missing TF, you can totally find out second is the unit that is to be put there. So you can then remember that the filling time was the one that you are missing. So just remember this formula like that by remembering the units, or by just taking into account what the units here are used, or what the units here are, how the formula here is written. And it is mass divided by this kg meter cube into second into correction factor into meter per second. So this is the velocity of gate. So this is the V3 or VG. So this is correction factor, filling time, and this is density. So this whole will give you choke area, which is the minimum cross-sectional area in all of gating elements. And now we have this question, the part of the gating system which regulates the pouring of molten metal, it is choke. The choke can be placed near the sprue well to slow down and smooth out the flow. Choke is placed on the gate to make removal of the part easier, but includes extreme turbulence. So there are two ways, two things that we can do. We can place the choke in. So choke can be placed near the sprue well So it can be placed here also and it can be placed here also, and they both are having this uh, limitation and advantages that I have shown in the screen. In gating design, the gating ratio is 4 is to 2 is to 1. So what is gating ratio? Let's see that. So gating ratio is sprue area is to runner area is to gate area. So it is always in this order. First we have sprue area, then we have runner area, then we have gate area. So this is the gating ratio. And in gating design, the gating ratio is 4 is to 2 is to 1. So you can see that it is 4 is to 2 is to 1. So your sprue area will be having the largest size. From this gating ratio we can deduce that, and runner area then we will get the gate area to be the smallest one. So the smallest area is gate, so you can also deduce from that that it will be choke area. So what is given here, gating ratio is 4 is to 2 is to 1, which is always again I am writing in this order. It is used to produce casting of 20 kg mass, liquid metal density given, time given, height of the liquid metal above the gate given, HT given, and CD this correction factor is given. So what will happen, we have to calculate the choke area here, or no, not choke area, we have to calculate the sprue dimensions, that is sprue diameter, and to do that we need to calculate choke area, because choke area is equal to gate area because it is smallest, as 4 is to 2 is to 1 is the gating ratio. So therefore area of gate will be the smallest one. So if we can find choke area, we will find area of gate, and area of sprue is, from this you can say area of sprue is 4 times of area of gate. So we can find the area of sprue equal to this term, and from here we can find the diameter of the sprue. That will give us the answer in mm. It can be obtained. So this is the whole process you can do to find the answer here. Again, not that hard, but you have to remember the choke area formula to calculate that. And also you have to remember this gating ratio order, because you need here to know which area is choke area, and that is gate area here. And again, this is the gating ratio. In the gating system, the ratio is 1 is to 2 is to 4. What it is representing? So it is always representing sprue area is to runner area is to in-gate area. The rest of the things are not having this correct order. So the correct answer is A. Unpressurized gating system and pressurized gating system are the two gating system that we have to study for the gate, which is involving placing of choke area into different places or different locations. So first choke area is if it is at the base of sprue, that is bottom part of the sprue as shown in the figure, then we will have this velocity of the liquid metal entering into the cavity will be less, no turbulence and splashing because of less velocity, because after it is passing to the choke area, the molten metal will flow through this runner and the losses will be obtained there. And since there is no turbulence and splashing, therefore as I have discussed it again and again, you can use it for non-ferrous metal because of no oxide formation, because oxides of this non-ferrous metals are not worth having because of their brittle and hard nature. And a possibility of air aspiration will be there, and casting yield here will be less. So air aspiration is occurring here, that's why red tick, and casting yield is less, that's why red down sign. So casting yield less, we don't require that, and possibility of air aspiration because of this choke area at the bottom, this possibility is there because of negative regions occurring in the sprue, where the low pressure negative regions will lead to that mixing or sucking of the air aspiration air there, the gases that are generated, and it will mix with the liquid stream, and obviously there will be porosity in your final casting, which is not desired. So gating ratio is always this. So if the gating ratio is 1 is to 2 is to 2, then here area of sprue is less, so you will say that this is unpressurized gating system. If it is this also, then you will say this is unpressurized gating system, as area of sprue is less, and it is therefore choke area. So we have a pressurized gating system now. So what pressurized gating system is? Pressurized gating system is simply choke area is at the gate region. So choke area is at the gate or in gate. Velocity of the liquid metal entering into the cavity will be high, and turbulence and splashing will be there due to high velocity. Therefore, it is good for ferrous casting, not good for non-ferrous casting. So we will avoid using pressurized gating system there. And it is also not good for light alloys. Remember that. And no air aspiration due to back pressure. So there is a back pressure here due to we putting the least area at the gate. So this will lead to no air aspiration effect, which is very important. And you have to simply remember this line, that no back pressure, and that back pressure leads to no air aspiration effect. Casting yield will be more, and therefore this is positive point, that there will be no air aspiration effect, and casting yield is more, that is also a positive point. So we are finding this much, this one better than the unpressurized gating system. And due to back pressure, it is also, you can just relate or just say that it is called as pressurized gating system. And if the gating ratio is 1:2:1, then also we will take it as pressurized gating system, because here you can see AG and AS both are least and both are equal, but still we are taking this as pressurized gating system because of the area of gate being the smallest, and which will lead to this whole advantages. So gating ratio, if it is simply 2:2:1, then it will be pressurized, it will also be pressurized. So remember this thing. And that will be it for pressurized gating system. So pressure at the in gate will be maximum in the gating system. So which is the gating system, which gating system is providing us the pressurized setup? So that is the first one. And D also is providing that, as we have seen, but D is not that much better, because here we can simply say that 3 is less than 4, but here both are equal. It is still pressurized, but the correct answer will be A. Solidification time calculation. So we follow this Chovarinov's principle to calculate solidification time, that is time taken to solidify, to make that molten metal which has filled the cavity to become solid. So that time will depend upon this ratio V by A square. So this square is very important. Don't miss it. So if we remove the proportionality sign, we will find K, solidification factor, which is having unit second per meter square, and it can also be written in some other unit, but basically above term is time and the bottom term is length square. So we have V, which is, I have told you before, V is representing the amount of heat available and A is representing the heat transfer. So if V is greater, then your solidification time is greater, and for that V, if area is less, then your solidification time will be greater, and if area is more, then your solidification will be less, because more heat transfer will be taking place, and therefore it will solidify soon. So TS, that is solidification time, it is also inversely proportional to thermal conductivity, because thermal conductivity will lead to more quick solidification, therefore time will be less. And specific heat is also it is inversely proportional into, because more change into the temperature will be occurring for less amount of heat. And thermal diffusivity, we can also say that the solidification time is inversely proportional to that, because thermal diffusivity is nothing but this K by rho Cp, and we can see that the thermal diffusivity is greater if then the temperature will be diffused, or the heat will be diffused properly, which will lead to a less time solidification. And riser solidification time should always be greater than cavity, because if it is not there, if the riser solidification time is not greater than the cavity solidification time or the casting solidification time, I should have written here casting, then what will happen? Your riser will be of no use, because when the shrinkages will be there, then your riser cannot just compensate that shrinkages, and there will be shrinkage cavities at the center, which will obviously make your final casting weak and defective. So now we have certain shapes which you have to know. This solidification time is having V by A ratio, so you should be knowing what V by A is for this certain geometries, and you can totally calculate this while solving the questions during your GATE examination, but it is obviously proper to just look into them once, or if you can then just remember this final ratios, because if it will waste don't waste your time by calculating this on the spot. Here it should be A square. So for cube, V by A is A by 6. For cylinder, we have to simply calculate it, and here it is the total surface area. So remember to multiply 2 here, not just surface area, total surface area, not just curved surface area. Elliptical cylinder is having this formula, slab is having this formula. For slab, we have to be very careful when we are doing question, because as you can see, there are a lot of things to calculate here. We have to multiply LBH, and we have to find the perimeter, which is having quite a bit of more calculation than the rest of the things. And sphere, you have to remember that it is D by 6, V by A, it is always D by 6. And for cube, it is always A by 6. These are the common ones, you should totally remember them. And if you are using radius, then do R by 3, because D is equal to 2R, so that 6 will become 3. So these are the formulas that you should be totally remembering, or just look into them, so that you can find yourself doing some familiar calculation. Solidification time is important in casting because it affects. So solidification time, here is some notes that you have to here are some notes that you have to just remember, and these notes are just sharing some important values, not values, information that might get asked as a GATE theoretical question. So solidification time, or it can just improve your concept. Why we are studying solidification time? Because it is important, because it affects production rate and hence process economics. The resulting microstructure and hence properties are also affected by this solidification time. Chauvinov's principle is having this formula where K is solidification factor, and it is depending upon metal and mold material both, and it is depending upon their density, heat capacity, and thermal cavity, conductivity, not cavity. We have this question where we are given with two cubical casting of same material and sizes of as you can see, we have two cubical casting, same metal, and sizes of 2 centimeter and 4 centimeter are molded in green sand, so moisture one. And if the smaller casting solidifies in 2 minutes, then you have to find the solidification time of this large casting. So you can simply do this equation question by just writing this 2 divided by TS2 is equal to V by A of 1 square V by A of 2 square. So you can get the answer from there. With a solidification factor of and also this question, if you have properly understood, you can do this very quickly, that since the cubical casting is having V by A ratio, area ratio as A by 6. So if it is the area is changing by 2, then its square will become 4, and your final casting will be solidifying instead of 2, 2 cross 4, 8. With a solidification factor of 0.97 into 10 to the power 6, the solidification time of a spherical casting of diameter 200 mm is. So again, very easily we can calculate this. We have to just write this 0.97, it should be 0.97 into 10 to the power 6. It is second per meter square. So write this diameter in meter here. So it will be d by 6 for spherical. So it will be 0.2 by 6 square. So after you do this, you will find the final answer, and what it is, let's see, since it is not having that much calculation. So we can totally do that here. So it is coming out as a B. So again, these questions are done very properly, very easily, without involving a lot of calculation or without wasting a lot of time. You can do this, and this again 2 marks question, but it is very easy. So I expect you to just just understand the usage of all this formula properly. Just do questions, quite a few of questions from each and every topic, so that you can get a proper idea, and you can solve this questions easily, which are having this 2 marks. So don't take time, so you can totally get the time for solving hard questions. Volume of a cube of side L and volume of a sphere of radius R are equal. So we have a cube of side L and a radius of R, that is of sphere, and both volume are equal. Both the cube and sphere are solid and of same material. They are being cast. So it is east, it should be cast. The ratio of solidification time of cube to that of a sphere. So we will have V by A of cube divided by VB by A of sphere, and don't forget the square here, and volume will be same, so we will cancel them out, and we have to just find the ratio of this casting area, and it will become like this. So this will give us the answer, and you can find the correct answer by doing this. It is not that difficult. So again, volume, you can totally cancel them out, and rest will be providing you the answer. In sand casting process, a sphere and a cylinder of equal volumes are separately cast from the sand molten metal under identical conditions. The height and diameter of the cylinder are equal. The ratio of solidification time of the sphere to that of cylinder. So we are provided with height and diameter of cylinder equal, and we have to find solidification time of a sphere to the solidification time of cylinder, and they both are having equal volumes, and by this equal volume we can find a relation between their diameter and this cylindrical dimensions, and after that we can get the answer. Again, this question you can totally do. I will not be doing the calculation here, because again it is not that difficult. It is just calculation. The basic concept I have just provided you how to solve it. A cube shaped casting solidifies in 5 minutes. And by the way, if you are wanting to solve this question one after another, you can find the PDFs when you visit my profile. Follow it, the link I have provided in the beginning of this class. So use that link, follow the just follow me there, and you can attend the classes there, and also download my notes there. A cube shaped casting solidifies in 5 minutes. Solidification time in minute for a cube of same material which is 8 times heavier than the original casting is. So a cube shaped casting solidifies in say 5 minutes. So TS is given as 5 minutes for case 1. For case 2, we have to find TS if your mass is now becoming, M2 is becoming 8 times M1, and therefore mass will be density into volume, so it will be like this, and the same material, therefore density will be same. So we can say, since this is cube, a2 cube is equal to 8 times a1 cube. So you will find that a2 is equal to 2 times a1. So by doing that you can find the answer here, and which by the way will come out, since this is 2, so this will become 4 after because v by a will become a by 6, and if you do square there, the 2 factor will become 4, and your final answer should come out 20. Solidification time of a casting is proportional to v by a square, that we already know. V is the volume of casting, a is the total surface area of casting. Just remember this total surface area. Two cubes of same material and size are cast using sand casting process. Top face of one of the cube is completely insulated, so its area will be reduced, and solidification time of cube with top face insulated to that of cube with other cube. So since one of the cube's face is insulated, it will take more time because it is having less area to just do the heat transfer. So you will find that solidification time of insulated top face insulated will be K. V by A for cube is A by 6, but here the top face is insulated, so it will become A by 5, and here it is square. So what if we do the ratio, we will find that it will become 36 by 25. So simply we have done the calculated this top face insulated value, and that value will be, which is having no face insulated, it will be A by 6 square. So if you put the ratio of this top face and bottom part will be this normal one, then you will find this 36 by 25, which is the correct answer. A cube and a sphere made up of cast iron, each of volume given as 1000 centimeter cube, cast under identical condition. Time taken for solidification for cube 4 seconds. We have to calculate that for sphere. Again, this question is not that difficult, 2 marks question. So this type of questions, if you done once, then you can totally be very well prepared. So I am expecting that you do all the previous year GATE question paper from casting at least once, so you can totally get a good grasp of this solidification time calculation questions. And as you can see, you are having a lot of questions. GATE has asked a lot of questions from this topic, so it is better to prepare this completely, fully and properly, so that you can do the question in fastest possible time, and also without making errors. Ratio of solidification time of a cylindrical casting, height is equal to radius, not height is equal to diameter here, to that of cubic casting of side 2 times equal to the height of the cylindrical casting. So another geometrical different here is given relation, but the process remains same. The same formula you have to use, and you will be getting the same answer. You will be getting the answer similarly, not same answer. So just use this formula and use just think about the geometries properly and do this. You can do this question again, not that difficult, and I have done this in one of my classes, so not waste time here because we have to cover all the casting revision topics. Solidification time of a metallic alloy casting is directly proportional to its surface area. No, it is inversely proportional to, or inversely proportional to square of the surface area, inversely proportional to the specific heat of the cast material. So that is one thing that you can say, and inversely proportional to the thermal diffusivity of the mold material. So that you can also say inversely proportional to the pouring temperature. So it will be directly proportional to the pouring temperature, but it will be inversely proportional to thermal diffusivity of the mold material. And what thermal diffusivity is, it is equal to, you can say that it is 1 by K by rho Cp. So you can say it is only inversely proportional to thermal diffusivity of the mold material. So I think I have written one thing, it should be directly proportional, I think, because if specific heat is greater, then what will happen? Your solidification time will be greater because it will require more heat to make that temperature change which is required to solidify. So this will be directly proportional, and you can see from this thermal diffusivity formula also, which is K by rho Cp. So we have this 3 questions left for this slide. Equal amounts of liquid metal at the same temperature are poured into 3 molds made up of steel, copper, and aluminium. The shape of cavity is a cylinder with 15 mm diameter. Size of the molds are such that outside temperature of the molds do not increase appreciably beyond the atmospheric temperature during solidification. Sequence of the solidification in the mold from the fastest to slowest is, so we have to find which is having the least possible solidification time and which is having the highest solidification time, in that order. And we are provided with K, thermal conductivity, specific heat C, P, and the densities. So we can find the thermal diffusivity K by rho Cp, and we know solidification time is inversely proportional to this thermal diffusivity. So by doing this, we can get the answer of which material is having the smallest solidification time and which is solidifying the slowest. So again, not that of hard question, only 1 marks question, and question is quite big, but it is just providing you the required information to do this question. And thermal diffusivity, let's talk about it. It is K by rho Cp. High diffusivity means high heat transfer, or you can say high diffusivity means heat transfer is rapid, and it measures the ability of a material to conduct heat energy relative to its ability to store thermal energy. So Cp can be seen as ability to store thermal energy, and K is shown as ability to just conduct the thermal energy. So K by rho Cp is just giving you the measure of ability of a material to conduct the thermal energy relative to its ability to store the thermal energy. A spherical drop of liquid having 4 mm radius solidifies in 6 seconds. What is the solidification time of the same drop with double radius? So again, it is quite simple. Solidification time will be K into V by A square, and that V by A ratio is equal to D by 6 for a spherical shape object, and from that you can easily calculate the answer to this question. So again, that is it for this part also, and let me just give you this information that use this code to watch free classes on Unacademy app and website, and follow me so that you can get Unacademy. Find me at unacademy.com, where there I will be taking some other classes, and I'm also planning to take thermodynamics. So there you can also find some exclusive content. So just go there, follow me, and just subscribe to Unacademy, start your preparation, do all the things that I have told you, and let's see what we have in the next part here, and if we should continue that or if we should just do that in the next class. So we have this riser. So let's do this into next class, since I don't think a lot of you watching live. So I will be making sure to continue this class next time. But now I think we have discussed a lot for today, and we should totally just end it here. And before ending this here, let me just show you that gate combat Unacademy combat thing. So let me just play the video.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So that was the GATE Combat or Unacademy Combat competition that is going to start from 16th of December. So you can totally take part there. And again, follow me on unacademy.com. Visit the classes. You can take part in classes there, attend the classes there for free. And this is the link. So you should just enter this link on the browser and just visit my profile. Follow me there. You can find my notes here in the PDF form for your revision, and also find my classes there. And in the unacademy.com we can interact in a more better way, and you can I can give you live quizzes which you can attend at the spot, and there are a lot of students who are just discussing or just learning there, so you can totally go there and learn with those students. Use this code to watch free classes on Unacademy app and website. The app is free to download, and you can also use this code to get 10% discount if you are just planning to get an Unacademy subscription. So this code has multiple benefits, but first of all, just go to Unacademy website or download its app and enter this code and watch free classes. So that will be it for today's class. If you found this class helpful, then hit the thumbs up button. And if you found this class engaging, just like this video, subscribe to this channel, hit the bell icon for notifications. 10% off code is ABHIMI, which is also giving you the access to free classes and free notes. Again, visit my just profile. I have given you the link, and just subscribe to Unacademy and start your preparation. So that will be it for today's class. And test series you should start giving it as soon as possible, and it is better to just take the test series from Unacademy and give them, because they will be providing you analysis which will help you a lot, and you will find that your GATE marks is improving exam per exam after you are analyzing it properly by using the analysis of. So thank you for watching. That's it for today's class. Best of luck for your preparation. Stay safe and take care. So thank you for watching.